Without further ado, good evening, everybody. How are you tonight? Very well. Thank you guys for coming out to UACNJ tonight. I do see we have our face coverings on, so I really want to thank you for that. It's something new that we are required to do, and by us following our social distance, by us wearing our face coverings, we were actually allowed to open up at a very reduced capacity this year. So I do thank you for making the reservation. To my side, my left, your right, we have our gift shop over here. I mentioned to a few of you earlier that if you do go in the gift shop, we do ask that you go in one at a time. Unless you're going to accompany a little one to go inside, then we encourage you to please walk your child in there as well. Observing is going to be done tonight up the driveway. We know all the clouds are going to move out of the way, so we're going to have a really good night of viewing. Fingers are crossed. 2 huts on the left will be open. Unfortunately, this season, you are not allowed to go inside the hut. We're going to project all the images outside for you. One more thing before I turn this over tonight to Michael. Right in front of me here, we are a donation-based organization. Everybody up here you see is a volunteer. He's a volunteer helping us out doing the talk tonight. He's a volunteer over there running the camera, myself as well. So we ask that if you're able to, you can make a donation here. You can also go to uacnj.org, scroll down on our homepage, and you can make a donation there. And if you can't, that's perfectly okay. We just ask that you enjoy your program tonight. With that being said, you're going to get a great talk from a friend of ours who's been here before. He's also a fellow New Jerseyan, and he's going to tell you some fantastic information about the Mars rover. So I'm going to give the floor to Mike, who is a NASA Solar System ambassador. So if you folks do have any questions, feel free. Ask him during the talk. If not, Kim will be out at the end, and she'll go through the audience and address any additional questions. So, floor is yours, Mike.
All right, sir. Thank
you.
All right, thank you for joining us tonight. And I see there's children as well. That's great. We're here to talk about the new Mars rover mission that was launched July 30th this year from the Cape Canaveral Kennedy Space Complex. And just a little bit about that history. I know we have a lot to talk about tonight, and I'm excited to show you these things that I have available for you. I've been doing this since 1996, and at that time I was called an ambassador from Jupiter. Yeah, I know. That's kind of weird, right? And I used to get, of course, ribbed about that. And how I got interested, I'm a physics science teacher, and I love to teach about these things because it's just something that I've shared since I was a little kid. When I looked up in the sky at the telescope, I had my own 50 power and used to gaze at the moon, and we landed on the moon. And that was the beginning of my desire to be part of the NASA program. And of course, when I learned to fly, doing my PhD and all that stuff, I thought I could become a NASA astronaut, but they don't call them that. I should tell you a secret. They're called flight mission specialists. And so, talking to Mario Ronco and some others that had been selected, it just seemed like the space program for man wasn't going too well. Let's put it that way. And after a few applications, I realized, no, I wasn't going to get picked for it. And so I still kept in touch with NASA, and I noticed one day that this is when the internet was just beginning in 95. I noticed when there was a spacecraft, Galileo, that was coming into Jupiter, and I was following that on the internet, though. Internet speeds were so slow back then, if you remember. But they had made an error on the presentation then on the screen, and so I contacted the webmaster Ron Balke at NASA, and that led to my becoming involved. I'm one of the original 13 of the NASA Solar System ambassadors, and I always get this good stuff. that I'd love to share with you. I present at the planetariums, the museums, at schools, on my spare time. So without further ado, let's look at what happened on July 30th. I'm going to have to sit down here. Excuse that, since we're under different arrangements. But the Mars 2020 launch on July 30th was prepared for several years. We have not been to Mars with a rover since 2012, though we did land a stationary Explorer, InSight, about 3 years ago. And that's been actively looking at seismic activity on Mars. But the preparation that went into the Mars Rover 2020 was something to follow, if you have followed it, that led to using several new advances in landing and studying Mars. So we can talk about those, leading to the launch window. After all that preparation for several years, the testing, the shaking, the baking that's done, there was a launch window. And here I'm showing you a time graph here, where you can see where there's always a possibility that launches will not occur. And these occur from, we had the first window beginning on the 30th of July at 7:50 a.m. And it continued until August 15th. If it didn't go then that would have been a scrub, and we'd have to wait for 2 years. But it successfully went on the first window. I'm sorry, oh, you can't hear. Yeah, it successfully went on the first window on the 30th, and it launched exactly on time. I don't know how many of you saw it. I was up. I was definitely psyched for it. And this Titan just took off, and it went off beautifully. So I want to show you what it looked like, if those of you that did not see it, on the Atlas, the Atlas V541 rocket, and it was on Launch Complex 41. Now in 2020, it's unfortunate that we have to have security measures, because back in the 90s, I was able to actually travel to all of the launch complexes and saw where Mercury went off, where Gemini and Apollo were launched, where the Venus launches occurred, and the Pioneer, Mariner, all of those. A civilian was allowed to go on at that time. If you had permission, you could request it. And now, of course, you have to go on a bus, and they prevent that. But anyway, they launched, and let's take a look at what it, did you see it? Now, those of you who are interested, on the website of mars.nasa.gov, you can go and see some multimedia resources. You can build yourself an Ingenuity helicopter 3D model. You can get stickers. You can get, I'm sorry I don't have posters for you. It's one of those things, because of the virus, we're not transmitting those kinds of things through the mail. But I did bring some lithographs about astronomy that I've had for a while. Also, if you'd like to follow the Mars Rover 2020, there are two websites on Twitter and Facebook where you can see where things are traveling there. So I do want to talk about that. Anyway, here is a picture of a rocket launch, very similar to the one that you're going to see. This is the New Horizons one that is now traveling out in the Kuiper Belt, which occurred in 2006. Okay, so here is the launch, and it looks like I'm going to have to go to, you have to excuse me, I'm going to go to the internet real quick. Or I downloaded these before, and so let me show you what it was like when it was launched on July 30th. It's always exciting for me to see these.
We're headed to Mars, ready to ride a column of fire and smoke on its way to the red planet. And liftoff as the countdown to Mars continues. The perseverance of humanity, launching the next generation of robotic explorers to the Red Planet. And that must be you have gone closely to identify your reverse course. And we have successful separation of Mars 2020 with the Perseverance rover.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.
From this perspective, you can see former shorelines curving around ahead.
Okay, so it will arrive February 18th, 2021. Okay, so let's go back to the slides. And what happened? Okay, so here we go. I guess it happens. It goes back. All right, so here we are. We are at Astronomy site, and I have another one for you called Eyes on the Solar System. And this gives you an idea of where the spacecraft is located at this time on its route to Mars. So let's take a look at that. And here you have a picture of the solar system. And there's our sun in the middle. Let's go through. I have to work this with you. All right, so let's see what you can see here. I know it's kind of fuzzy tonight. But here we have and here's our sun, and here are the planets. It's not as clear as I'd like, but you can see where Mercury is, and out here where we have Mars is out here. And at this point, you can see that the spacecraft is about halfway in between the Earth and Mars. It was launched July 30th. It's now September 26th. This is nearly 3 months, 2 months, right? Let's see, yeah, I did this before. It's almost 2 months from it, but we're traveling to, we're right in this region. I don't know if you could see my hand moving, but we can look in even further with this, and we can look on the side, and we can go right into what the spacecraft is doing, which is a very interesting thing. Notice the other spacecraft that are out in outer space right now. We have this Parker Solar Probe, which is looking at the sun, and we have the two stereos that are looking at the sun on both sides. So there, I've got it flipped around. Let's flip it around again. There we go. And you'll see here that the spacecraft is at this point. Now, where is Mars in position to the Earth is one of those things that astronomers love to know. So let's go there. And this is the information that an astronomer will use to determine where the Earth is in relation to Mars. Okay, so I have to do this with you. Up here, we're going to conjunction with Mars. If you've been following Mars, Mars has been up in the night sky. You've seen Jupiter and Saturn, right? Now we don't have any probes going around Saturn anymore. We had the spacecraft Cassini, which took several years to reach it from the Earth, and it became one with Saturn a couple of years ago. And then we have a spacecraft that's going around Jupiter called Juno. You can go on the website and look at that. All these missions are successful, right? The ones to Mars, not so good for a while. The young ones don't know this, but those of us who are a little older, when I was first selected for the ambassador program, we had 2 Mars spacecraft that went to Mars, one called the Mars Polar Lander, that was going to land on the Mars North Pole. And we had another one called the Mars Climate Orbiter. Both of those missions failed. And that was after the success of the first rover called Sojourner, the little rover that landed on Mars. And so at that time, because of those 2 disasters, there was a rethinking of how to do missions. Okay, so here we have a celestial map. This is the Earth's orbit. This is in blue. Now, the Earth orbits our Sun approximately 365.25 years. Mars, however, is twice that amount, 730 something days. Did I say years? Yeah, 365.25 days and 730. So at this point here, this is going to be coming up October 5th. Mars will be at its closest point to the Earth, right, in conjunction. Okay, so now we have the Earth is orbiting, and here we have February 18th, right here. And you'll see here that at this time, Mars is in the winter. It's in his winter. This is what this is telling us. But this is up here, it's coming into winter. Yeah, as a matter of fact, it is in winter, everywhere. And each one of these is the months, March, April. When we come out here, this is May. This is May for, so the equinox for Mars is like May 8th, and we're in February 18th. So you see, we plan the missions so that Mars will land, the rover will land, hopefully successfully, when Mars is starting to get warmer, begin to get warmer. So that's a little bit there. And then Mars will be in what we call opposition in October of our October 8th, 2021. So that's when it's behind the sun. So that'll be an interesting time. But by then, the rover will have done quite a lot of exploring. So let's talk about what the rover is going to be doing. Okay. So that's just a little bit. And if you want to know a little more information, this is available on the website about Mars. Okay, so after the launch, the rover, as you saw, is now in not a hibernation state, but it's in between hibernating and activating. But it's continually being monitored where its location is. That's why you can see with the eyes on the sky where in the orbit that it is between Earth and Mars. Okay, so I thought that might take care of some questions that you might have later. All right, so where is the rover going to land? Now this is the exciting part, because before we've had to be very careful to land in a place, as with the polar lander, we weren't careful, and it found its way, we believe, somewhere in some kind of rocky crevice and is lost. It didn't transmit. It landed, and then we believe it fell down somewhere over some rocks and cliffs or whatever. So it's not exactly known. But these are places that we'd like to visit. Several of them, the North Pole again, the South Pole, and then we have these other places: Arabia Terra, Jazeera Crater, Terra Meridiana, and Margarita Terra, South Pole Cap, Hallis Basin, very interesting place, Hortus Crater, and here we have Syrtis Major. Well, that's where we're going, people. We're going to Syrtis Major. So let's take a look at this. This is a close-up of the area. I'm just going to come up here and stand because I don't think that pointer's working too well. Here, I can take off my mask. Speak a little bit clearer. All right, so this is called this is the basin. This basin here, and I'm going to show you the depth. This is like, it makes Death Valley look like a mountain almost. It's so deep. You have to walk down this thing. But this is where we're going. It's called Jazeera Crater. It's located right here. This is the Sirtia area here, and this is the Jazeera Crater. So you can see here, there's the craters here and here. Innies and outies, right? Is it an innie or an outie crater? Okay, so there is a nice picture of Syrtis Major, and okay, so here you have Acidus Basin. That was the region before, and on the side here, up here, you have MOLA, which is the Mars Observatory Laser Altimeter. Notice here in purple, it's negative 5,275 meters. Right, that's like 2 miles down. 2 miles down in this basin. That's like an ocean. That may have been an ocean. Mars billions of years ago. And over here is this Jazeera Crater. And you can see here that it's like, these are higher regions here. This is going from a negative 5,000 to a positive 4,100. Quite a difference in altitude between the two. All right. So that's this Jazeera Crater. How come we can land there, right? How have we learned to land in a place that's so nice? Well, to give you an idea about improved landing precision. All right, this big ellipse over here, this big one, this is the big ellipse. This is from the Pathfinder. All right, this is the Pathfinder, like 97. This huge area. And then when we did the Phoenix and the Insight landers, right? Those are the ones that they're immobile. They don't really move around. This was the ellipse, right? Okay, so now we're so good, and you'll see why in a little bit. We have this small ellipse. To give you an idea, this is like 300 times better of navigating than this larger ellipse. And this is our target bullseye there. That's the Mars 2020. Okay, so why is that so? Right? All right, so let's take a look here at why that is. That's right. It's because we have what's called this terrain reference navigation. All right, with MSL, those are the Mars surface landers before. That's what we call them, Martian surface landers. We have the rovers after Pathfinder. We had Spirit and Opportunity, right? And then we had the Surveyor. Okay, so here we have some of the things that we're using on the 2020 called Perseverance. So the improved EDL, I usually ask questions of the audience about an EDL. EDL means entry, descent, and landing instrumentation. So now we have these suite. We have a suite. That means many instruments and sensors available for us to implant. And you can see here we have a heat sensors here. We have pressure sensors, right? And we're able to also take pictures as Perseverance is coming down. So here now is a quick video of how the EDL has improved. So we're going to first take photos. You're going to see more of this later, and we're going to look at the orbital map. Now, as the rover is going to land, as it's entering, it's going to be monitored. We have several Mars orbiters going around Mars at this time. We have the Mars Reconnaissance Orbiter, we have the Global Surveyor, and the one long before, like in 2002, we have the Mars Odyssey. So it's amazing that these spacecraft just keep performing. And you can see here that we're going to start taking these photographs miles up, 100 miles up. And we'll be looking at the trajectory. And the rockets on the lander will guide. And this is all done automatically. Okay, so it takes time for us to send a signal and get a signal back from Mars. It's not like you can just say hello on the phone and then you get a hello coming back. It doesn't work like that. Mars is 20 minutes away, so it's like a 40-minute round trip. So this stuff has to all be done remote control, all pre-programmed. Everything pre-programmed. Now, because we're able to take these photographs, and you'll see how that's done in just a moment, we can land in much more dangerous places and not have the spacecraft be lost. And we call it terrain relative navigation, terrain reference navigation, TRN. If you look up that on the internet, you'll see that there's like 40 or 50 acronyms, meanings for TRN. Okay, so this is where the EDL system will look. It looks like a lot like Curiosity's one. That's the one in 2012. And there's been a lot of new improvements made. And we used a lot of new hardware, but there was a lot of old hardware. That was one of the things that we saved money by taking what we had from Curiosity that we didn't need, putting it onto Perseverance. So that was pretty cool. Anyway, here is a short little snippet on what it looks like with the helicopter coming in. I don't know if you can hear it. This is where they were testing the EDL system. Now this is near Death Valley. We have a deep space network out there at the Goldstone Radar facility. That's the sensor detection system in the front of the helicopter, coming back from its test run. And it made more than just one. There were several test runs made. Fun to be a helicopter pilot doing that stuff, right? Okay, so let's look at the next one. And here it is. This is what it will look like. This is what Perseverance's cameras will be doing as it descends. And it goes through a series of sweeping motions, right to left, left to right. And those are cameras here at the bottom. You can see Elvis. Did you see a picture of Elvis? That's Elvis, the sticker. Yeah, they've got sense of humor, believe it. Yeah. So this is over Death Valley, and there's some mountainous terrain near it. So it's coming in. It's simulating what the cameras will be doing on Perseverance. Okay, so let's go on to the next one. This picture here will show what this terrain reference navigation actually does. So we'll play that. You can see here that these squares, okay, so it starts out with lots of squares in this lower right-hand corner. And then up above, this is when another camera is taking photos instantaneously almost. They can do this, it's so quick. And this is all done remotely. This is pre-programmed. And that's one of the things we do when the spacecraft's en route. We fine-tune the programming. We can do that because we test it again on Earth. So this is continually, though it seems like they're not doing much in the program. Actually, in the background, we're continually testing to see if we can't make it even better. As you know, technology is like that. We're able to, because it's unmanned, to put the newer materials on board. So let's take a look at that again. So you can see how we get a large site and we refine it. The spacecraft's coming in and it gets an idea of where it looks better. In green, red doesn't look good, green looks good. Blue, blue is best. Let's see if we can follow in blue. Alright, so that's how it works in Death Valley. 110 degrees outside. Okay, so here is Jazeera, and we've already got it mapped out. We have the global surveyor, which has the most powerful lens ever made on an orbiting spacecraft. There's some spy mission that we don't know about. I don't know, Defense Department, but anyway, we have here this is where it'll work on Jazeera. So there you go. I hope you can see that clear enough. Alright, so there, that's pretty cool. And don't worry, you're gonna spend the time on watching this when it is live. It won't be live, it'll be a few minutes after live. They'll be posting it. Alright, so that's new on there. Alright, so here for the entry, descent, and landing cameras. Here are the series of cameras, and there's 6 of them here. And you can see this, the long range ones. Here, let's stand up this one. Alright, so how are these cameras working, right? Well, you have the cameras that are looking down, but also there'll be a parachute, and you'll see that soon. There's a parachute that'll slow the descent. And a camera's going to be pointing up for making sure that everything is fine. Now remember, since this is we can't control any of this from where we are on the control center. This is hoping that it's happening, and we're waiting for those signals as they come in. And don't worry, it'll be live on TV. NASA TV will have this back ahead in February. All right, and so they have the down look when the descent is occurring, and then you have above at this point, when it reaches this point, Perseverance, the rover is already descended. It's on an umbilical cord, hanging. It's suspended. All right, and so then the rover is now looking up at the descent module, and then we have the rover down looking. A sequence of series of events that occur then. All right, so okay. I don't think you can get this on the internet. I'm sorry, but I don't think they have all these things. Okay, so since we the other Mars surface landers, when they've landed, and also from like Odyssey and the Global Surveyor, we've been able to map the gravity around all of the globe, around Mars, all around it. And the gravity anomaly, it's not always equal. We want to look at a place where the gravity is less, where it won't pull the spacecraft down too fast as it's going to land. All right, so you can see here at the bottom how that will be done by the spacecraft a little bit there. See the veins moving back and forth to adjust the landing area. Okay, so there we are with that nice. This information is already. This is downloaded. This is in the spacecraft. So all of these things are ready to rock and roll when it gets down there. Okay, so to test to see if this would work, right, it had to be launched, and it was. So let me show you a little launch here. Okay, so there it's launched into near Earth orbit, 150 miles up or so, and then we check to see the strengths of the parachute. Okay, so what does that look like from outer space? And here we have another video. And so this is what we're simulating the entry. Of course, it's on the Earth's atmosphere, which is more dense than Mars. And you can see there how the spacecraft's entering the atmosphere. Okay, so that's how we test. Now here's the interesting video that I love to show. Let's go through this one. It's a little long. It doesn't have much noise. Let's start it. Okay, so this is what will happen when on February 18th the spacecraft will enter atmosphere. The good thing I downloaded this stuff beforehand. Anyway, I hope you can see this. All right, so here's the entry capsule. It's holding the spacecraft in. It's holding Rover in there. And so here's Mars. The trajectory has been, like I said, pre-planned. Here's Mars below. Here's coming in. And it's moving. I don't know if you can see here how fast it's moving, but it's traveling at like 15,000 meters per second, which is 30,000 miles per hour. It has to be slowed down. So that's why it comes around and it continues its ride, and it's descending slowly. But it's still moving very quickly. All right, at this point, it's decelerated to about 10,000 miles per hour, and now it's at, believe it or not, 5,000 miles per hour, and it's slowing this quickly. The rockets are slowing to 2,000 miles per hour here at this point. And there's the zone, there's the target area, there's Jazeera. The spacecraft is still moving at 1,000 miles per hour. All right, right there. It's going now about 900 miles per hour, 480 meters per second. And it's at an altitude of about, what? Let's see, I can read that, about 1,000 kilometers up. It's still way up, 10,000 kilometers. So that 10,000 kilometers is about 16 miles. So here the parachute's deployed. And here we have now the separation between the heat shield. The heat shield comes off, and immediately the sensors on the capsule and enclosed are sensing the ground. All right, so we're going now at about 250 miles per hour down. We're now at 700 kilometers up. So we're way up. We're still up. All right. So here we come down. Yeah, the altitude is up. And it does take time. We have to slow it enough. So now we're at 500 kilometers, about 400 miles up. Now we're about 250 miles up. You can see the yellow, the lights extending. Now, can I make that bigger? Interesting. All right. Larger. And so now the zones are illuminated. Now the spacecraft, it's still descending at like 200 miles per hour. And it keeps coming down. Keeps coming. And parachute's there. Now the zone has been refined enough so that the rover is descending. And it keeps coming down. And you can see the trajectory that it's on, moving along this line here for entry. Okay. And at this point, it's still traveling about 70 miles per hour. But now the rockets come on to slow the descent. That is the above. And now we're going to land. There you go. That lands, it comes up, and then it's going to fly away. It's going to pop off. And this module is ejected. Okay, so now it's on the surface and looking out. Okay, so that's that one. Alright, so I tried to I did not download a couple of these, unfortunately, ahead of time. And I was hoping that you could see this, what it would look like from a closer viewpoint. I don't know if it downloaded yet. But I do want to show that to you. So let's look at that one. So this is the flyby. Yeah, it looks like it'll play. Alright, so we'll play this. Jazeera Crater Flyover. Alright. It's playing. Kind of slow. There we go. So what will the trajectory look like? Okay. Close up. And this is where we were looking earlier. Hopefully you'll be able to look through the telescope at that point and see it. Mars will still be in. Okay, so this is from orbit. Playing slow. But you can see here these are great pictures of the Mars surface. And here is a zigzag. See how it's going to zigzag as it lands. This is a proposed. This is the area where it will land. And okay. I don't want to spend too much time because there's some others that I'd like to show you on this. Okay, so this is a nice picture. This is real color. It's not enhanced or anything like that. It's from Ken Farley. He's the lead scientist. Alright, so this one's playing slow. Alright, we'll go back. I'll stop it. So there's also the sample collection one. There's a little animation of what's going to be like on the rover when it lands, and I'll show you the rover in just a moment. Let's see what this one looks like. This one downloaded. Sorry, I didn't download these beforehand. These are the only two that I didn't. I didn't think it would be quite so slow. This might be a little quicker. So here's the rover. We're going to show the drilling and caching animation. That's connected to this. But again, it's slow. Fortunately, that might be a little bit better. Let's see. Now you can see how big the rover is. If you're not sure how large that is, that's as big as an SUV. And the mast here, the head of it, the top of it is replicating a human head, approximately 6 feet tall. Okay, so this one's playing a little better. Alright, so you're going to see the we're looking for life on Mars. That's the big thing. And we believe that Jazeera Crater is one of the best places for it. We've been tantalizingly close. Viking, it was believed that they did find some microbes, but ambiguity resulted in them discounting those findings. And here's the drill. Okay, so it's doing pretty well here. So this is a very advanced system, solar powered, everything solar powered. This is the previous Pathfinder, and the others have been similarly equipped with solar panels. And here you have the drilling that's going to occur. This drill bit's going to go pretty far. You want to ask how far? I believe it's at least 1 foot down. That's 25 centimeters. Then it's going to take a sample, and this sample hopefully will be returned to Earth one day. It's going to be analyzed, at least with a little laboratory that's on there. The Curiosity had a mini science laboratory on it, but not nearly as complex as the one on Perseverance. Okay, so you can hear microscopes, different powers that'll be in effect, and we'll look at that again in more detail in a few moments. Alright, so this shows us what can happen with the drilling. So I'll stop that one and we'll go to what's a very interesting thing is just to look at the different parts of the Mars rover, and here they are labeled. So take a look at this. I don't know if this is available online, but I can show you some stuff here before I show you the helicopter. So let's take a look at that. Huh. It's not. Come on. This was downloaded earlier. Maybe I have to go back. Yeah, I have to go to Google then about that. Okay, so let's see if I've got it here. Let's see. Yeah, here it is. So I already downloaded it, thank goodness. Here are the wheels. The wheels are aluminum, right? They've got the cleats for traction, titanium spokes, springy support. And we have another one at Pasadena that's located there. All right, so we can learn about the wheels, 6 sets of wheels. This will prevent it from getting stopped. And Curiosity's had problems, the one in 2012, because it gets stuck in the Martian soil. Some of it is not dry; it's moist. So there's water. There's plenty of water in Mars. If you've seen anything about that, it's a subsoil. So here we have the wheels. Let's go to another part of it. We can look at the body. Okay, here's the body. This part here, and looking down on it, you can see the various parts that are there. This body it protects the computer. It's got electronics. It has to keep it warm. Mars is very cold, and Mars just has such a hostile environment on the surface. The Martian, right? The Martian movie is one of those that is pretty good at explaining more of it. Okay, so here we have the cams. There's a nice computer on here, the one that runs everything. It has 2 identical. One is a backup. We found that you needed to have backups on everything, whether it's an outer space mission traveling out to like Voyager or New Horizons to Pluto and the Kuiper Belt. Backups right here, the computer system, and the backup hidden underneath. Okay, so let's look at some other parts just to show you how many cameras there are. We have the front cameras, front has cams, and we have the rear ones. They're all over the place on these things now. The rear ones, let's go to the rear ones, come on. Right there. Okay, it's not showing us the rear ones. Alright, we'll look at the mast. Are you getting any of that? No. Okay, I have to come out. Alright, so here's the mast. It's going to rise up. I'll show you a nice little clip. Here's an arm, as you know. There's one more arm. That's the one that we just saw a video of. There's navigation cams. Okay, 2 eyes, stereoscopic. Really good stuff here. Lots of interesting material. And we have microphones, so we're going to hear for the first time. We're going to listen. We're going to record the sounds of landing and others. We're going to study Mars rocks that way as well. So we're going to hear the winds of Mars. Might see a dust devil or two, and listen to that as it goes by. So, like I say, there's a duplicate Perseverance on Earth, and like I say, they test it. It's continually being tested now. All right, so let's go back and let's look at what else is. This is a big surprise that's happening on Mars. We have a little helicopter that's on the rover. And I'm going to show you that video now. I think it's the most exciting thing I've seen in a while with the helicopter. So let me play that one. Here it is. And, the helicopter is held underneath Perseverance. It weighs only 4 pounds, but it can fly for 90 seconds and travel about 900 feet. So let's take a look at what this is. So this is the helicopter. And I hope that others wish they had stayed for this one. There's a little solar panel above the blades. And the rover pulls away from it, and they communicate. And there, it's going to be on the surface. There it goes. Travels for 90 seconds, can go about 300 feet up in the air. And there it goes. Yep. Rover's going to keep an eye on it. There she goes up. Flying around. She'll take pictures. It's like a little drone there on the surface of Mars. If that's not about the coolest thing, we're on another planet, and we're not okay. So for those of us who've been around since '97 with the Pathfinder, okay, in 23 years, that's how far we've come, right? It's amazing to me that we're that far. Okay, so that's the Mars one. And I don't know if this will work. Yeah, no, it's all right. You can learn more about it. Technology helicopter there. Okay, they have a STEM, science, technology, engineering, and mathematics toolkit available for if you'd like to learn more about the behind the scenes stuff of the math and the engineering, how they were able to put all these things together off the shelf. It's amazing to me that we can do that so inexpensively compared to other missions that were so much more before. So here was the online. You'd register if you wanted to be part of that, and I followed it. It was too much. That was back in the day. And there it is right there. This is the Curiosity Mars rover. It's climbing a hill, but the Perseverance is much harder than the others that have been there. And we're really looking for success. So I guess that ends the presentation for tonight. So thank you for coming. I'm glad I could show you those ardent lovers of the Mars program and the other programs. So any questions? I'm sure there's questions tonight.
All right, I'll be walking around with Mike when you have questions. A few things to note, because I know some people probably want to get out and view through the scope. We do have 2 telescopes open. I don't think they're going to be viewing anything because currently we're cloud covered. We do, yeah.
Oh, gosh.
We do have
So nice out.
pictures up from previous nights projected for you that were through the scopes. A couple notes, we do have the porta potty to my right, your left, should you need it. When you are leaving, please use your headlights because getting run over hurts. With that, are there any questions? Hello?
No questions? Truly. Wow. Well, I did anticipate there would be questions about what season it would be when, the rover landed. You don't want it to land in winter. Mars winters, you think we're cold. I mean, we're talking like minus 150 degrees Celsius. But during the spring and the summer, the temperatures will rise to a balmy like 10 degrees Celsius, above freezing. Yeah. February 18th? Or 18th, yeah. Well, that's it. It's the equinox, just after the equinox on Mars, where we have equal sun. We just passed our equinox right on the 22nd of September on Earth, where Mars has seasons just like we do, and it's in the northern hemisphere. If you notice where Jazeera Crater was, it's in the north, and it'll begin warming up. It'll begin warming up enough that there won't, hopefully, no dust storms, because dust storms are, have you ever seen maps of the dust storms on Mars? They just sweep the planet. I mean, it's an amazing thing when that happens. How quickly they happen, how quickly they disappear, but they're very, very destructive. This resulted in the failure of, we had the Mars Rover Opportunity, which was, it landed in 2003 and it was operating for over 15 years. Yeah. And eventually, when the dust storms got it, it covers the solar panels. Remember, everything is powered by the sun. There's no radioactive material. We're not contaminating. That's one of the problems, right? You may wonder. I mean, many of you might be an environmentalist. Everybody should be caring about our environment, and that's one of the things. If you saw the personnel who are working on this mission, they keep the room that's vacuumed. It's like a white room, and they're similar to how we make semiconductors for our computers, where you can't even have a human hair on the spacecraft. Trying not to put anything that is carrying, but I'm sure there's bacteria or something, that they get on everything. It's one of the difficult parts of trying to maintain sterility.
So at the beginning you mentioned that years ago, I think 15, 17 years ago, there was a rover type device that was there and landed on rocks. So my question is it just debris that's left there?
Well, you mean when the rovers stop moving, you mean? Or yes, there is debris, and we do see it. That Mars Global Surveyor, you saw the pictures of Jazeera Crater. It can actually see the previous spacecraft that have landed on Mars and take nice pictures of them. Yeah, and the thing is that it's hard to believe that these spacecraft are still operating 17 years, 18 years after Mars Orbiter. The Odyssey Orbiter is still orbiting Mars. It's still functioning, which map It mapped the altitude. It mapped the water content. It mapped many, and besides doing visual mapping with the different places with its cameras and lenses. So then we had the Mars Global Surveyor. Like I said, that's like a spy satellite going around Mars. How many miles up are these things from Mars? Well, just a few hundred miles or so. Mars' atmosphere is very thin, mostly made of carbon dioxide. And so that's one of the problems. But could we habitate Mars? Yes, there's the future that it could be possible. But if we do so, I believe we have to begin underground, building structures underground. And of course that requires digging equipment, things like that. So.
All right. I do have a question from
Sure.
someone online. Do we have an estimated timeline for when manned missions would go to Mars?
There we go. You know what? I'm not even going to go there with that. It's so difficult to say. I mean, we have the technology right now to go to the nearest star system. You don't believe it, right? But we could. We could send a space probe out there, and say if you lived another 20 years, we could see the spacecraft going to Alpha Centauri, Proxima Centauri. So it's not really. We have the technology to go there now, but it's the will. We're not even on the moon. So it's much simpler to send unmanned spacecraft. A lot cheaper, safer. People worry about other people and the dangers of going there. I'm sorry?
Yeah, so on the Mars they put the people, so there is a television series.
Yeah, that's the thing. In Hollywood, you can do anything, you know. In Hollywood, we can go Star Wars, you know. We can visit Tatooine. Let's go to Tatooine. I'm a Star Wars fan. So George Lucas just blows my mind. He did those things back in '76 with the first Star Wars, Episode 4. Right?
Right. That wraps up our online questions. Was there any more questions or comments from the audience? All right. We want to thank you guys for coming out. It's been great having you. We are a nonprofit organization. Your donations, even through this tough time with COVID, have helped us continue to keep bringing you the free public programs. And we thank you very much for that. Again, we do have some projectors up with images from previous nights. We do have the gift shop right behind me. And I want to thank you for being our speaker tonight.
Diane, is it?
No, I'm Kim.
Tim, I'm sorry. Tim, thank you very much for having me.
All right.
Thank you very much for being a lovely audience. And I hope to come back next year and show you the stuff that's been happening, especially with the helicopter. That thing is just going to be an amazing thing. Integrity, yeah. Okay. Thank you so much.